Welcome back to the deep dive. So last time we were really getting into the weeds on the fundamentals of cloud storage block, object, and file.
Right.
And that was kind of like buying the land and putting up a giant warehouse for all our digital stuff.
Exactly. We covered the raw storage, but, a warehouse full of stuff is pretty useless if you can't find anything.
Right.
Databases are that next critical step. It's all about organizing that raw data, giving it structure, so when you ask a really complex question, you get a fast, reliable answer.
I like that. So it's moving from just a warehouse to a really well-run library.
A library, exactly.
Yep.
A searchable, efficient, well-indexed library.
Okay, let's do this. Our mission for this deep dive is to get our heads around the two huge competing philosophies here, relational and NoSQL.
And not just the philosophies, but the specific AWS services built for them.
Yes. And crucially, we're also going to talk about the performance booster that sits in front of all of them, caching. We want you to walk away from this knowing not just the what, but the why.
Why an architect picks one over the other. Because that choice, relational versus NoSQL, it really defines everything about an application today. So we should probably start with the old guard,
Relational databases.
the traditional choice, the ones that run on structured query language or SQL.
So why are they called relational? What's the core idea there that makes them so rigid?
The core requirement is integrity. That's the whole game. Think of them like a very strict set of linked spreadsheets.
Linked spreadsheets, okay.
You have data in these fixed tables with rows and columns that you define up front, and the relational part is key. You create explicit links between them.
Using like an ID or something.
Exactly, a shared ID.
Hmm.
So you link your customer table to your order table using a customer ID.
And that means, so if I try to create an order for a customer ID that doesn't exist,
So the database just says no. It refuses the operation. It literally enforces reality for you.
that's huge.
It is. That's what
Wow.
people mean when they talk about ACD properties. Atomicity, consistency, isolation, durability is a guarantee.
A guarantee you'd absolutely need for something like, what, a bank?
A bank, an inventory system, payroll, anywhere you need absolute certainty that every single transaction is valid and recorded perfectly. That integrity is the superpower of relational systems.
That makes total sense. But I know that kind of integrity, that structure, it comes with a cost. There's that old joke about relational databases that they only scale vertically until you run out of ceiling.
That's the critical trade-off, you're right. They're amazing for complex queries, for joining all those tables together. But to handle more traffic, you have to scale vertically.
Meaning you make the one server bigger.
Right. More RAM, more CPUs, a bigger and bigger machine, and eventually you just hit a physical limit, and those machines get incredibly expensive.
Which brings us to the AWS solution for this whole problem. Amazon RDS, the relational database service.
And RDS is, you should think of it as a management service, first and foremost.
A management service.
Yeah. It handles all that operational heavy lifting. The patching, backups, setting up redundancy, scaling the hardware, all that stuff for the traditional engines you already know.
Like PostgreSQL are my household.
Exactly. PostgreSQL, MySQL, MariaDB, SQL Server. It turns what used to be a full-time job for a database administrator into basically a configuration exercise.
Okay, so RDS manages the traditional guys, but then there's Amazon Aurora.
Ah, yes.
That sounds like AWS trying to rebuild the engine itself, not just manage it.
That's exactly what it is. Aurora is a complete redesign. It's compatible with PostgreSQL and MySQL, so you still use SQL and get all that structure.
But the inside is different.
Completely different under the hood.
Yeah.
The genius of Aurora is that it separates the compute, the part running the database, from the storage where the data actually lives.
And what does separating those two things get you?
A few things. First, insane durability. It replicates your data 6 times across 3 different availability zones automatically. But the real key is speed. Because that storage layer is decoupled and super optimized, Aurora can get up to 5 times the performance of a standard MySQL database.
So you get the integrity and the transactional certainty, but with way more horsepower and resilience.
You got it. It's for when you need classic relational ACD properties, but you also need serious high-end performance.
Okay. But what happens when your data just doesn't fit, when it's messy, or when your biggest problem isn't integrity, but just massive unpredictable scale?
Then you have to shift your entire philosophy. You move to NoSQL, not only SQL.
And that's a conscious trade-off, you said. What are you giving up and what are you getting?
You're giving up the rigid schema. You're giving up those complex real-time joins across tables.
And in return,
You get extreme flexibility and, this is the big one, the ability to scale horizontally.
which means adding more cheap servers, not one big one.
Exactly. Instead of one giant server, you can have hundreds of smaller ones working together.
So if I'm building, say, a system for comments on a website, one comment might have a video, the next is just text. I don't need to have an empty video column for every single text comment.
You don't. These databases use models like key-value pairs or, more often, documents, like a JSON object. The schema is defined by your app, not the database.
So I want to add a new field to a user's profile tomorrow.
You just start writing it. You
Mhm.
don't have to go and do some big, costly migration on the entire database first. It's incredibly flexible.
That flexibility sounds great for developers. But the real power here seems to be that horizontal scaling you mentioned. That's what makes it work for these huge global apps.
It's the absolute key. NoSQL databases were born for this. They're built to just distribute the load across thousands of servers if needed. If you're running a global gaming leaderboard or logging, billions of events from IoT devices,
You need massive throughput.
massive throughput,
Yeah.
which means super fast data addition. And you need to be able to spread that data out efficiently.
And when we're talking NoSQL on AWS, the name that always comes up is Amazon DynamoDB.
DynamoDB is the flagship. It is a fully managed key value and document database, but its architecture is it's pretty revolutionary. It's entirely serverless.
Serverless, meaning I, as the developer, never even think about a server.
You never provision a server, you never patch a server, you never even think about capacity planning. You don't have to guess if you need 10 servers or 50. The service just handles it for you as your traffic grows or shrinks.
That's incredible.
Yeah.
But the performance claim is the real hook here. They say single-digit millisecond performance at any scale. How is that even possible?
It all comes down to how it partitions the data. DynamoDB uses this really sophisticated internal indexing based on the primary key you choose. So when you make a request, it knows instantly which partition on which server holds your data.
So there's no searching around?
No searching. It's a direct lookup. And because it's built for that specific task and distributed globally, that latency promise actually holds up, whether you have 10 users or 10 billion. It's the go-to for user profiles, session stores, anything with huge traffic.
Okay, this is great. We have Aurora for structured integrity and DynamoDB for flexible, massive scale. Both are super fast.
Right.
But the story doesn't end there. We have to talk about caching. And my question for you is, why? If these databases are already so fast, why do we need this other thing, this caching layer, sitting in front of them?
That is a critical architectural question. And the answer is that even the fastest database, Aurora or DynamoDB, still involves, a network trip and reading from a disk, a persistent storage disk.
It's a fast disk, but it's still a disk.
It's still a disk, and the latency is still measured in milliseconds.
And milliseconds add up.
They absolutely do. A cache works on a completely different principle. It stores your most frequently used data in RAM, in random access memory.
On a separate cluster of servers just for that task.
Exactly. And RAM access it's just a different world.
We're talking orders of magnitude faster, right?
Correct. You're going from, say, 3 to 5 milliseconds for a fast disk read down to microseconds for an in-memory cache lookup, often less than 1 millisecond.
So if you have a website and everyone is asking for the same thing over and over.
The current price of a stock or the most popular product page, yes, you offload all of those requests to the cache to RAM. It gives the user a massive performance boost.
So it's not just about speed, it's also about efficiency. You're protecting your expensive database.
You're shielding it. That's a great way to put it. It's a huge cost optimization, too. You want your powerful database doing the hard work, like complex writes and ensuring data integrity,
Yeah.
not serving the same profile picture a million times.
So what's the AWS service for this?
That would be Amazon Elasticache. It's the managed service for running these popular open-source caching engines. The big ones are Redis and Memcached.
I've heard a lot about Redis.
Redis has really taken over because it's more than just a simple key-value store. It can handle more complex data structures, lists, sets, leaderboards. It's incredibly versatile.
So the strategy is always the same then. Your application checks the cache first.
Always. You check Elasticache first. If the data is there, that's called a cache hit, you serve it back in microseconds.
And if it's not there, a cache miss.
Then, and only then, do you make the slightly slower call to your main database on disk.
It's like a performance turbocharger.
It's the ultimate performance turbocharger,
Yeah.
especially for applications with spiky traffic.
Okay, we have covered a ton of ground. We've got relational for integrity, NoSQL for scale, and caching for that raw speed boost.
The three core pillars.
Right. So let's try to solidify this for everyone. We're going to run through 3 quick scenarios, and you, our listener, should try to figure out the right tool for the job.
I like this. It really helps to reinforce the trade-offs.
Okay, scenario 1. You're building a new banking application. The system absolutely must guarantee transactional integrity ACID properties are non-negotiable. And the main feature involves complex queries that join data across customer accounts, loan ledgers, and transaction tables. What's your choice?
Well, the requirements here are just unforgiving. Strong consistency and complex joins.
Those words just scream one thing.
They scream relational. The need for joins and ACID properties immediately rules out NoSQL. You are structurally required to use a relational database here. No question.
So the answer is either Amazon RDS or, for better performance, Amazon Aurora. Integrity is king.
Absolutely. You just don't compromise on that in finance.
Perfect. Scenario 2. You are launching a new global social media app. You need to store tens of millions of user profiles. And, critically, the product team is moving fast, so the definition of a user profile is going to change constantly. Plus, you have to be ready for massive, unpredictable scale.
Okay, so when I hear unpredictable massive scale and flexible schema that changes constantly, my brain immediately throws out the idea of rigid relational tables.
Right. You don't need complex joins in real time.
Not for a profile store. You need horizontal scaling and schema flexibility.
So the ability to just scale out on demand, no capacity planning, no schema migrations, that's a perfect fit for it.
Amazon DynamoDB. The serverless architecture is just tailor-made for that kind of high-velocity, unpredictable world.
Excellent. Okay, final challenge. Scenario 3. You run a very popular e-commerce site on Aurora, and it performs great most of the time. But during big sales, it just grinds to a halt. You find out the database is getting hammered by millions of identical requests for the top 100 products and for user session data. What service do you add?
This is the classic efficiency problem. The database is working, but it's doing dumb, repetitive work.
Work it shouldn't have to do.
Exactly. You need to intercept those millions of requests for data that doesn't change very often and serve it from the fastest possible place.
Which is RAM.
Which is RAM. This is the textbook definition of a caching problem. The solution is to put Amazon Elasticache right in front of that database.
You nailed it. And by thinking through those scenarios, prioritizing integrity versus scale versus raw speed, you now have the main tools you need for organizing and optimizing data in the cloud.
Yeah, this deep dive has really taken us from just having piles of data in raw storage to having a really organized, optimized system. We know how to store it, structure it, and serve it fast.
But, as you said earlier, structure and speed, that's not the whole story. The data is only useful if it's secure, if access is controlled. We've built the library, but who gets a library card?
Exactly. You can have the fastest, most well-organized library in the world, but if anyone can just walk in and read the most sensitive documents, you have a catastrophic failure.
And that thought leads us directly into our next deep dive.
It does. We have to talk about who can do what.
Next time, we are focusing on the absolute core of control: security, identity, and compliance. Because in the cloud, nothing is more important than defining those boundaries.
We'll show you how AWS services make sure that only the right person with the right permissions can touch the right data at the right time.
We will see you then for our deep dive on security, identity, and compliance. Thanks for joining us.